I'm sure all of you are really familiar with pi. All right? Euler number is something like a pi. It's just a number. It's an irrational number. So, what you need to learn today is establish the limiting definition of Euler's number, E, and then evaluate the limits in terms of E. You need to be able to simplify expressions using the index law in base E. E is just a number. All right, it's just a number. Think about it as it's just a number. Solve simple exponential equation using class pad. So you do need a class pad. If you have got one, come and grab one for me, please. And then solve graph function in the form of y equals to a e to the power of bx minus c plus d, which again, remember your transformation from last year. And then identify critical features of that. Now what we're going to do is, I'm going to introduce E. And tomorrow, we will look at y equals to e to the power of x, and then how we are going to find the first and second derivative of that. All right? So, you should all recall from last year, when we have got y equals r to the power of x. You know that r is just a ratio between the first two numbers, and then x is the exponential. All right? The value of y is always greater than 0. It cannot be less than 0, unless there is a vertical translation. If not, it's always 0. So when x equals to 1, y equals to r. All right? Now, what we're going to do is, instead of r, a ratio, we're looking at a particular number, Euler number. So introducing Euler's number, it is an important constant. It's similar to pi, but it's not pi. It's found in many contexts and is the base for natural logarithms. We'll look at the two natural logarithms. All right? It is irrational number that's derived from continuous rate of growth. It is used a lot in terms of exponential growth. Things like compound interest, things like growth rate, and that sort of stuff. All right? So E is 2.7182812828, so on and so forth. Don't worry about writing it down. We'll probably be concentrating on the first 4 or 5 numbers, that's all. All right? Now, in the exam itself, or test itself, if you're not asked to evaluate, leave it as E. All right? Just like leave it as pi. It's just like a exact number. All right? So now let's establish Euler's number, E. If you think about the compound interest formula, A equals to P, 1 plus R over N to the power of NT. Now, if you've got an account which pay an interest rate of 100%, which is really highly unlikely, but we have to look at the situation in order to be able to establish what E is. All right? So if you invest $1 in that account, at the end of the year, what happened? N is 1, compounding period is 1. All right? T is 1 year, and R is 100%, which is 1. So 1 over 1, 1 plus 1 over 1, to the power of 1, that's 2. So therefore you doubled it, correct? Now what I want all of you to do is grab your calculator up, or if you like, use your spreadsheet. Think about it, if we compound it half yearly, quarterly, monthly, or fortnightly, or weekly, or daily, hourly, every minute, and every second, or continuously. Keep going, keep going, keep going. What would happen to the balance? So if some of you do quarterly, some of you do monthly, some of you do fortnightly, and we can compare the answer. So we have got investment of $1, the P is $1, R is 1, so N half yearly is 2, N quarterly is 4, monthly is 12, fortnightly is 26, weekly is 52, and daily is 365. And maybe some of you do daily or hourly is 365 times 60. All right? Or you can do every minute if you like. So it's 365 times 60 times 60, and so on and so forth.
No, don't you have to times it by 24?
Sorry?
24 for hours.
Ah, yeah, per hours. Sorry, yeah. Thank you. daily 24 hours times 365. So if I've done it correctly, these are the compounding period. It goes bigger and bigger and bigger and bigger and bigger and continuous. Alright? So every 8 seconds, every 16 seconds, and so on and so forth. Now, if you do those sort of numbers, what do you get? If you keep on going, just try it out. Just maybe try 365. Or some of you try 8760. If it works, it actually approximates 2.71828818, which is the Euler's number. As it goes bigger and bigger and bigger and bigger and bigger and bigger, you actually find the Euler's number. This is the basis of Euler's number. Think about how you would determine it. Alright? So the N is the compounding period because R is 1, T is 1. So we are looking at N only. Right? So keep on going. You started from 2 and you will just slowly move back until you get 2.71828818. Now, what this number is, A equals 1 plus N to the power of N. Can you get your class pad out, please? What we are looking at that number, 2.71828818, is actually the Euler's number, Euler's constant E. So if it is observed from the table that as n approaches infinity, the value of the balance A approaches a limiting value. The limiting value is denoted by E, the Euler's number, which is 2.71828, and you've got, that is the notation for E. Limit n to the infinity, 1 plus 1 over n to the power of n. Alright? You need to know the theory, but generally, looking at the test paper, we're just using E most of the time. I haven't seen anything that will ask you to derive E at all. Alright? So you just need to use a calculator. Grab your calculator out and use and see whether you can find where E is. Now, let's go to example 1. Can you use class pad to evaluate the following before decimal places? E is just a number, nothing else. Think about E as just a number, that's all. Alright? E is just a number. Battery? Yes. Remember in the exam? Okay. Here I can help you. In the exam or test, I won't be able to. Although, waste, no, okay. Really, for this year, I want all of you to have a spare set of battery. Alright? It's so important. I remember last year in the waste exam, for the apps exam, someone forgotten their class pad. Luckily, we generally walk around. You know, the supervisors will not lend out class pad because they don't want to handle school properly. That was what happened. And recall somebody actually did not have the batteries as well. So please. Now, that is what I got. E to the power of 3 is just a number. E is just a number. 2.71812 to the power of 3. Should be able to find the square root of E, E to the power of E. Just type in E to the power of E. E to the power of pi, or pi to the power of E. Pi, use the pi in your class pad. Pi to the power of E. Yeah. Jerry, is everything alright? Okay. So, check your answer. This is what I've got.
No idea.
Now, you know the reason why I'm getting you to do this basic thing is for you to realize that E is just a number. Nothing special, and that's it. Now, example 2 will be slightly trickier. All right? Let's go to example 2, please. You need to be able to use that function, max to limit something something. So let me call out my my classPad emulator, and we'll work on it together for the first one. So the first one is limit n to the infinity. Math 2, limit n to the infinity. Right? So what I would do, instead of n, I'll just use x to infinity. The infinity sign is there. Alright? This time, what I will do is put the bracket in, 2 brackets. Put the bracket in. 1 plus 3 over x. Alright? Bracket to the power of x.
Whoa, it's the same
Put that
thing.
in. And then if you tap it, you should get 20.08553692. Alright? Do the first, do B and C. D is just the same, but this time, what you need to do is change that to 1, and that becomes 3. I'm not going to show you the answer yet. Alright, I want you to look at D, E, and F. See if you can notice something, and then compare it to the answer from A, B, and C. A is 20.08553. You must make sure that you put in 2 brackets. The bracket outside is limit x to 0. And then inside the bracket itself is 1 plus 1 over x, another bracket to the power of 3x. Alright, make sure you do that. If you don't do that, you will not get the right answer. So what you really want to put in is in the calculator with one of these. Alright? That's how you do it in the calculator. Alright, although you write it this way. Now, I've got all the answer. Can you notice something between A and D? B and E and C and F.
They're the same.
They are exactly the same. Alright? Keep that in mind. What's the difference? What have I done here? What have I done here? I've taken the 3 out and became the power. Minus 2 out became the power there. So 5 is out here.
Yeah.
Alright? So it's a coefficient. I brought it up. So what I'm saying is that, so the exponential function, it's just writing it that way. You really, what you need to know is this. Y is A equals to E to the power of x. Alright? So here is the limit n equals to 0. This thing itself. Alright? This thing itself, if I can draw it properly. Alright? So limit
essentially showing
n to the infinity, 1 plus 1 over n to the power of n, that equals to E. Alright? That equals to E. So that is your Euler's number. You need to know the limiting definition of the natural exponential function, which is the exponential function base e. I want you to keep this in mind because you'll be needing it in semester 2 when we look at the natural laws. So if we rewrite y equals, can we rewrite y equals a e to the power of bx in limit notation? It's still the same. It's just a limit n to the infinity. All right. Bracket 1 plus 1 over n to the power of bxn. That's all. Or you can say a limit x approach infinity 1 plus bx over n to the power of n. Alright? So you need to know the limit function for this. And then realize that e is an irrational number. It's just a number. So all the index laws apply. You got to recall back what I taught you last year in terms of the index law. And with that, can you please do example 3, please?
Sir,
Yep.
you know that those limits, could they come up in a test to evaluate them? Have you ever seen it in a test or exam before?
I haven't seen that in the exam or test.
Okay.
Yeah, I'll have a look at it again a bit more.
Is it just
carefully,
more
but
for
at this stage-
understanding?
Sorry?
Is it just more for understanding?
Yeah.
Okay.
I mean, that's my personal belief because.
Yeah.
But don't quote me on that. I'll just go through and make sure it is.
Yeah. All right.
Alright. Now, so for example, for part A, what does that mean? You need to use a to the power of n times a to the power of m equals a to the power of m plus n. Correct? So therefore, this is e to the power of 3x plus 3. Yeah? Can you try part B, part C, part D? And we'll work on part E together, please. Just do part B first. Part E is a tricky one.
It's not that.
Part E is a tricky one.
It is hard, mate.
No, no.
Yes, it is.
It's not.
It's for what do you mean? It's hard.
It's e to the power of 3.
E. You're saying E is e to the power of 3.
No, that. It's just the power of 3. The last one.
E.
E to the power of 3.
You said so the last one, the big
Yeah,
one,
yeah.
is e to the power of 3.
Right? No.
No, it's e to the power of 2. You dumb. Hey, you said it was easy, bro. How you get it wrong? How you get it wrong? It's easy.
Because I like additioned it, even though I shouldn't have.
For B, yeah.
Oh yeah.
No.
E.
Yeah. No. Yeah. E to the power of 3, yeah.
Are you sure? Isn't it?
What happens when you divide like indexes? Yeah, so it's e.
Isn't it
3x
2 e
minus
to the
5.
power of 2?
3x.
We're talking about B, right?
Oh, yeah, e3x.
Yeah, you just evaluate the numerator
Yeah.
and then just take away the denominator.
Then d is e turning it 1. Then e
Whoa. No need.
For
You don't
D,
even know the
factor
guy.
out E. Factor out E in the numerator.
You don't know the guy.
Wait, are you trying to just cancel out the things?
Yeah.
It's e minus e.
Yeah, but I'm not hating.
Yep.
So.
So what would you do though? Like if you got this right, E minus e to the power of x over x. What would you think? This is wrong. Oh yeah, sure. Yeah.
Then you just have e dividing
This here.
e dividing
So,
Oh, no,
you
yeah.
should be able to work out the rest. think about all your index law.
So then take away. Yeah, so take away. Both cancel out this with this. Give negative e. Then next step.
You can't do that. So you can't cancel these out.
Sorry?
Because imagine if I have this, right? E is just a number, right? Imagine if I have e equals 2. Of course, it's not actually 2, but we have 2 minus 2x over 2. You can't just do this, right? Okay. Well, imagine if this was like 6, right? You can't do that.
You just times it by the inverse of that. You times it all by the inverse of that.
Alright, I'll show you how to do it really. So what you can do is you can actually factor out e. This is one of the tricks that you get with it. So factor out e. Oh yeah, no, I'm just factoring out the numerator here.
All right. Now,
Because we've a multiplication, we can now cross it out.
have a look at answer. I haven't done E yet. So pretty much here is 2x plus 3x minus 5. Use your index
Cancel
law.
that one is a subtraction or plus. You only do
All right. E is just a number. 2x plus 3x because the index law there, and then take away 5. Here,
What'd you get, V, bro?
what I've done is eliminated or simplified the 3 and 15 first. So I've got 2 over 5. That is e to the 2x and e to the power of x. Or you can straight away cancel it, which is 2 e to the power of x divided by 5.
Nah.
Here,
You just gotta-
I've taken the e out. So I factorize it e out,
You're gonna times it by the.
and I could
you
eliminate
just factor out
one
e
of the
squared.
e, simplify that. So 1 minus e to the power of x minus 1, taking the e out,
the same.
because when you multiply that in, it would be e plus x minus 1. 1 plus x minus 1, which is ex. So therefore it simplifies down to 1 minus e to the power of x minus 1. So how are we going to do part E? Alright? Hey, what you need to do in this case, let's think about the denominator first. So I've got e to the power of x plus 1 plus e squared. Alright? Next, I'm thinking rewriting e to the power of x minus 1. E over ex, e to the power of x over e plus 1, which is e to the power of x plus 1 plus e squared. I'm doing step by step. Alright? E to the power of x over e plus e over e, which is 1. Correct? Yeah? So now, bring the denominator, the same denominator, which is e to the power of x plus e. I haven't touched the numerator yet. Do you all agree with me? Yeah? Now, what I'm going to do is rewrite this e to the power of x plus 1 plus e squared over e to the power of x plus e times e. Correct? And therefore, what I'm going to do is with the numerator, I'm going to rewrite it as e to the power of x times e plus e to the power square over e to the power of x plus e times e. Factorize the numerator, taking the e out. I've got e to the power of x plus e divided by e to the power of x plus e times e. Alright, so I can cancel that off, and I therefore have got e squared.
Sir,
Yeah?
why can't you just like factorize e squared out of the numerator, and then you get?
You can do that,
So
yeah.
you can get, there's only like 2
E
steps.
squared out of the numerator, yeah, you can do that as well.
Yeah.
Yeah, you can do that as well, thank you. So I did the long way. So if you factorize e squared, yep, thank you. That is more efficient way of doing it. I didn't even notice that. Factorize e squared. in the numerator. Which means you got e squared e to the power of x minus 1 plus 1. Yep, well done. I did not even see that. I went straight into looking at the denominator first.
So,
Yep,
can you factorize that one denominator from
Sorry.
yeah. How?
Yeah.
There are many ways of doing it. You can factorize the denominator with something else.
Yeah, so it's just e squared. Yeah.
Alright, let's have a look at the next one. Grab your calculator again. You need to be able to use your calculator to solve this. To do decimal places. Use your class back.
It's not even funny.
What's this?
Use your class back, please. So, for example, the first one. What you need to do is use your solve. You must be able, you're not expected to do it by hand, alright? Use solve. Oops. I need to clear all first. Use solve. Let's go to 2 e to the power of 1 minus x
If he's like dark, it's like tan.
equals 100.
It's big either.
Solve for x.
Yeah.
So x equals to 2.9120230005.
Swarm of times. Yeah.
This bit is pretty straightforward. Use your class back.
Yeah.
And the next one, solve. Alright, if you think about example 4b, there are actually many solutions according to your calculator, which is true. Alright, so there could be potentially more solutions. So it's given you 2 solutions in the class pack. So there could be more solution, class pack.
Use null factor.
But do we have to say there could be more solutions?
Alright, so there's one solution. The other one, I'm pretty sure, x equals to 0.35, I think. Alright, this one, I can't remember what it was. Minus 2.9120. Alright, let's go to the next one. I'm not sure why I can't write it. Alright, next one. Now this is from your syllabus, so therefore I need to show you this one. It's for your information. It's in the curriculum handbook. So another way of looking at Euler's number E. So if you think about Euler's number, we know that E is limit n to the power of infinity, 1 plus 1 over n to the power of n. Alright? So say if we write this without the limit notation, we assume that n is a very, very large number. Alright? Because n approaches infinity, so we can assume that n is a very large number. And if we let h equals 1 over n, since n is a very large number, h will be very small, correct?
Yes.
Do you agree with me? And then we can rewrite this h equals 1 over n, 1 plus n, h to the power of n equals to e. All right? And rearranging this, we know that we take the nth root of this is 1 over n, which is e to the power of h. Correct? From there, rewriting it, h equals to e to the power of h minus 1. And I divide both sides by h. Which means h divided by h is 1. This divided by e to the power of h minus 1 divided by h is 1. Now grab your calculator, please. Just play around with using use classback to do the following. Instead of e, I want you to use a. I want you to be able to establish a. I've given you some of the answer on the screen. All right? I want you to establish what a is. How do we find a? How do we equate a to e? So you need to play around with the numbers. You know Euler's number is 2.718. So if you start off with 3, then go down to 2, you can see that the number will get closer and closer and closer and closer to e. Closer and closer and closer and closer to 1. So if you've got those numbers, so 3, I think I've got another one which is 2. I don't know what happened, but it's coming. So if you play around with it, you can see that between 2.7183 and 2.7182, it's 1. All right, really 1, which means a, when that becomes 1, that is e. Right? Back to that slide. 1 equals to e to the power of h minus 1. See that bit there? That is so close to e. It's just a number. E is just a number. I just need to be able to establish it and show it to you. That's all. All right? We will do some application of e a little bit later. But I need to show you how this is done. All right, I've got a couple more slides to go. All right, I'll leave this out. You can play around with it at home. Now, I would like you to use your classback to plot y equals to e to the power of x. All right, use your classback to do that. And it should look something like this. I'm going to explain some of the things, some of the features. Have you all got it? Now, I've enlarged it using some other program. Basically, what I want to show you is what the critical points are. All right? E to the power of x. It will never be negative number. Y will never be negative number. So in this case, you can see that the critical feature of the graph are the horizontal asymptote, which is the x-axis, or y equals to 0. So the y-intercept is at 0, 1. When x is 0, what happened? E to the power of 0 is 1. So it's 0, 1. Then the other key point is 1, e. So if y is 1, x is just e. Alright? Oh, sorry, when x is 1, y is e. Wrong way. X is 1, y is e. And you can see that as x is increasing, y is increasing. X tends to infinity, y tends to infinity. And when x tends to negative infinity, y tends to 0. Yep. What was the question? So the graph will always appear above the x-axis unless it's being transformed. Alright? Unless there's a plus or minus d. Which brings me back to this bit here. Can you all remember your BCAT? No. Yes. What does B and C affect?
Horizontal.
Horizontal. And A and D?
Vertical.
Alright. D is always to me the most straightforward because it's just up and down.
Yes.
Correct?
Correct.
Yeah.
And then let's have a look at the order of transformation B cat from last year. So B is dilation parallel to the x-axis by a factor of 1 over B. Now, see what I've done there. You must always factorize the B out. Alright? Always factorize the B out. C is translation in the positive or negative, in the direction of positive or negative at x-axis by C units. So if C is positive, you translate it to the negative direction. If C is negative, you translate it to the positive direction. Alright? A is dilation parallel to the y-axis by a factor of A. Reflected about the x-axis if A is less than 0. Alright? Now, for the dilation parallel to the x-axis, reflect about the y-axis if B is less than 0. And then again, think about the translation, D up and down, the most straightforward. As soon as you see the D, that is your asymptote. Alright? That is always your asymptote. Now, if you're asked to plot a graph, make sure that you start off with the asymptote. Think about what the asymptote is first. Let's try this. Let's try example 5. Let's try example 5. So graph. Now, what would I do in the first place? The first thing I would do is, you know that that will be the asymptote, correct?
Yep.
Yeah? Sure?
So can we go to the toilet?
Just give it. Alright? You know that that will be the asymptote. Alright? Let's draw a line. That's your asymptote. Y equals to 1. I should be using ruler, but I don't have ruler, so or maybe I should use a ruler. Use a ruler to draw. Alright? I'll try using a ruler. Y equals to 1. So start off with, always start off with the asymptote. Now, what is the next thing? When x equals to 0, what happened? When x equals to 0, what would y be?
0.
Which is 0, 0. So that's a point. So when x equals to 0, y equals to minus 1 plus 1 equals to 0. So you've got 1 point already. Correct? And you know because it's negative, it's reflected by the x-axis.
Yes.
So the next thing is think about your critical point. Alright? You know that
Tattoo.
the original e to the power of x, it goes through 1, and then at point 1 is 2.718, that's e. Right? That is your e. Correct? Now, what you have done is you are actually going to multiply this by 2, correct? So that point will be taken out to here, right? And then it's going to be reflected, and then it's going all the way down to minus 2.718 when that's 2, something here. All right. Then the next thing is you need to actually translate it out by 1. So bring it all the way up by 1. So that point there, which is
Euler minus 1.
oops, 2 minus 1.718
Yeah.
is where this 1e has transformed to. So the whole thing will look like this, if I can draw it properly. Freehand.
Wow,
So
so
that is y equals to minus e to the power of x over 2 plus 1. Alright, that's how you do it. Think about the original, which is the green line, and then how you use the dilation factor and then flip it over, reflected about the x-axis, and then move up by 1. Alright, so this is how you do it. This is your graph. Alright. Next, determine the value of C and D. Here, what actually is D? Straight away you know that the asymptote is
-3.
y equals to 3, correct?
-3.
Negative 3. Is y equals to -3. So therefore D equals to -3. Alright? Now you are given this point, 2, 0.
I've actually never.
So you know that when x is 2, y is 0. 0 equals to
Where are you getting from?
3 e to the power of x minus c, which is x is 2 minus c minus 3. So therefore, you know that 3 e to the power of 2 minus c equals to 3, right? E to the power of 2 minus c equals to 1. 2 minus c equals to 0. Therefore, c equals to 2. Alright? This is how you determine your equation. Look at the asymptote first. So the asymptote is here.
You just move
Y
3
equals to minus 3.
divided
Always
by 3.
look at the most straightforward point.
Power to be equal to 1, it has to be 0. 80 to
Everyone happy with that? One last one. Okay, describe the transformation
e to the power of 0 is equal to 1.
that occurs from f equals to e to the power of x to gx equals to
This is 0.
2 e to the power of minus x plus 1 plus 4. Now, like I say, you need to factorize it out. Always factorize the
Do
b
you know
out.
that?
The b is not minus 1, it is minus 1, but you need to factorize it out so that you know the translation is whether it's left or right. So that equals to 2e to the power of minus x minus 1 plus 4. Always do that. Always factorize the b out. Alright? If not, you cannot tell whether it's translating left or right because of the minus there. So therefore, what you can say is this time,
Tends to
if it's negative, it's reflected about the x or y axis.
x.
X.
Oh, sorry, y.
No,
My
y.
bad.
Bro,
Y or X?
I said Y and then you
Right,
said
thank
X.
you.
I'm
So,
bro.
reflected about the y axis.
Hey.
No. Wait, why is there? Where's your reflection?
The y axis.
Why?
There's no dilation factor because it's 1. Correct? And then 2, step 2. Step 2 is translate in the positive x or negative x direction.
Positive.
Positive x direction because minus 1. By how many units?
Y.
1 unit. So it's translated.
You're gonna take the negative one out, yeah.
Translated in the direction of the positive x axis by 1 unit. Always say by 1 unit, alright? Always quantify it. And then 3. Is there a dilation factor for y?
Yeah.
Yes. So dilate parallel to the y-axis by a factor of 2. So that affects your y coordinate. And finally, you translate it up or down. Plus 4 is
Up.
up. So translated in the direction of the positive y-axis by 4 units. Alright, part B. As x approaches infinity, where does y approach? Where does y approach? So this graph looks something like this.
Negative
You know
infinity.
that,
Negative infinity, sir.
you know that it's something like this, alright? What is the asymptote? It's 4, correct? So therefore y approaches 4. So think about the asymptote as x approaches infinity, y approaches 4. I know it's a long lesson and I will finish it now. I'll finish the lesson now. So hopefully you know how I've established E, and tomorrow we're going to look at how we are going to actually do a derivative of E.